a word on the background that will be requisite to fully absorb these lectures. With all its sumptuous background, historical context, and narratives, we will be dealing fundamentally with a mathematical theory of chance, not a subjective or qualitative view of the subject, and accordingly, a student will need a modicum of mathematical preparation to be able to fully get the most out of these lectures. Not an alarming amount, to be sure. The preparation that is requisite is approximately equivalent to a semester of calculus. Something along the lines of what a student might see on a first year in college, or perhaps in an advanced placement course, or in an international baccalaureate program. More concretely, a student should need comfort with mathematical notation and mathematical abstractions to describe concepts. A student should be familiar with the ideas of variables, for example, using the ubiquitous n to represent a generic natural number or an integer, or the letter x to represent a generic real number. We'll occasionally use other variants on the theme. For example, letters like I, J, K, L, M, and N can represent integers. Letters like R, S, T, U, V, W, X, Y, Z may represent real numbers. But of course, generically, long tradition has conditioned us to thinking of integers as n, real numbers as x. A student will need exposure to the idea of a function of a real variable. In Euler's notation, we write these as f of x. We think of x as an independent variable, an abscissor, and f of x, the function, takes values as an ordinate, and we are familiar with the graphs of elementary functions. A student should understand and be exposed to the properties of the basic functions, linear functions, quadratics, exponentials, and their simple properties. A student should have exposure to sequences of real numbers and their limits, and elementary series, sums finite or countably infinite of real numbers, convergent or divergent. So, this is the scope of the mathematical background that a student should have. Of course, the more mathematics they have in their background, the more mathematical maturity, as it were, the better. But this is the minimum amount you should have if you really want to absorb these lectures as we go through. The differential and integral calculus make their appearances in these lectures only in selected bonus materials which are not essential for the grasping of the main elements that I'm going to unfold for you. Now, with all this for background, a student will also need some elements that are typically encountered in high school. And these are denoted, when they appear in these lectures, by this particular sign that has appeared on screen to denote something where you need work in your background. The elements you'll need are twofold: the elementary theory of counting and the elementary theory of sets. The theory of counting, we need to understand how to sample with and without replacement from families, from collections, the ideas of factorials and binomial coefficients. From the naive or the elementary theory of sets, we need to understand notation for sets, basic set operations, unions, intersections, complements, and set differences, and simple rules for massaging set identities, De Morgan's laws. These lectures are available as part of the preview, and for a student who is unfamiliar with these ideas or has had these topics and they are sequestered in the dim recesses of her memory and she would like a refresher, you will find these lectures available as part of the preview.